Today's video is about specific energy, a production by Robert Cadrell, Rachel Fritsch, Danny Heavey, and Konstantin Gogos. Make sure to like and subscribe after watching.
For an open channel, specific gravity is defined as the energy, or head, relative to the channel bottom as shown in the figure. Velocity can be rewritten in the equation as Q over A, and the area of the rectangle channel will be written as A is equal to Y times B.
For a constant flow, the specific energy can be plotted as a function of y, which is the water depth. As seen in the graph, y is the dependent variable, but it's plotted on the y-axis rather than the x-axis. This makes it easier for someone to read the graph.
Each curve on this graph represents a different flow rate Q. The x-axis is the energy, and the y-axis is the depth of the channel. YC is the critical depth, where the energy is the lowest. The slope at the critical depth is the critical slope at C. And when the depth is greater than YC, the slope is subcritical. And when the depth is lower than YC, the slope is supercritical.
Another way to know if flow is sub or supercritical is by calculating Froude's number. At critical depth, Froude's number is equal to 1. Supercritical, it's greater than 1. And at subcritical, it's less than 1. The flow in a system is not always constant. In many cases, it jumps from supercritical to subcritical abruptly. This is considered an hydraulic jump. In a hydraulic jump, the water moves violently, which causes a great energy loss. To show this in the lab flume is set to a steep slope and the wire is raised, causing the energy grade line to change from greater than critical slope to less than critical slope. This can be shown in the E versus Y graph.